Hello and welcome. In this series of videos, I'm going to take a look at this book, actually. You can see its webpage there in big. It's the Ray Tracer Challenge by James Buck. And it's simply a book explaining how to write a ray tracer and all of its inherent mathematics and algorithmics and stuff like that in a test-driven, test-first way. And I want to use it in order to get acquainted with a new language I'm looking at currently, which is Rust. Never written anything in Rust.
Hello, just a short intermission from a little bit wiser and older Jacob, which by now has done some of those recording sessions and some more streams, and has realized he forgot to tell you that there are information in the description below regarding the GitHub repository where you can get all the code we are writing here to follow essentially along. Furthermore, please bear with me while I'm still learning on how to present all the different things I'm doing currently during the recordings. I get better from recording to recording, from session to session, so please be a little bit patient. And now, back to the program. Have fun.
And I've decided to try and go ahead with this book, which was kind of a lucky accident I found on Twitter. Because a colleague, Sebastian Bergmann, is doing this challenge as well at the moment. So he's reading this book and doing all the chapters and implementations of this book as well. And I thought, yeah, that's a great thing. I've written a ray tracer a long time ago, don't know, 10, 15 years ago at least. But it wasn't a very complex one. I just wanted to get it to work, essentially, to properly handle certain kinds of ray tracing with reflections and stuff. And then I stopped. It was just for fun. I didn't really know what I was doing there. I just implemented it as best as I could. And now I thought, okay, this book is really nice. I like it. I like very much the idea of having this test-first approach, like the author is explaining how the ray tracer works with giving you the tests you have to fulfill, and especially this language agnostic concept of the book is really great, and I'm looking forward to working through all the challenges and implementing this. And I thought, yeah, well, why not record this for anyone to see how I'm stumbling into Rust and getting to know all this stuff and implementing this. So I will simply create videos of me creating the different different chapters and working through it. So yeah, let's get started. As I've said, never worked with Rust before. Actually, I've never really written a Rust project before, a Rust program before. I've not even written a Hello World. So I've somehow skipped through the basic Rust programming language book. And I've just installed actually Rust, which is explained here on how to do. I've just set it up to run. And now we are going to create our first project. If I have glanced correctly, we want to use Cargo for that. So it's kind of the package manager for Rust, and it does a little bit more. It is not only a package manager, it bundles stuff, it compiles stuff for you, it can scaffold projects and all sorts of stuff. So please bear with me if I'm not saying the right things here regarding Rust. I'm learning it as well as we are going along. So this won't be very fast, but hopefully it will be fun. So yeah, let's get going. So if I've seen this correctly, we need to do cargo new, and cargo new, let's say the ray tracer challenge. Is challenge? No, I always write challenge wrong. Sorry. So yeah, let's create this project. So it should have actually created a folder here. Yeah, and it has already some stuff in it. It has initialized our Git repository. That's really nice. Did it even initialize certain. No, okay. So let's simply let's say git add everything, and then let's git ci scaffolded project. So yeah. By the way, I will of course be pushing our progress, or my progress better there on to GitHub, so you can follow it there, you can play with it and stuff like that. So the first thing we need to do here is take a look at source. Okay, there seems to be a main RS, so let's open this project in my go-to editor here. Yes, I trust the authors of this this particular workspace. So let's have this here and let's take a look. We have a Rust file. Yeah, okay, it's kind of some Rust components not installed. Install. What is not installed? Can I see this? Well, maybe, I don't care. Just install. Ah, okay, it's installing Rust analysis. Yeah, then it should do that. Let's install Rust analysis. I've, by the way, installed the VS Code extension for Rust just before starting this recording. Okay, so let's make it a little bit bigger, but not so much so that we can see. We have now this print hello world here. Can we actually run this? How do we run this? Shouldn't be that hard, because I've seen that cargo can help all that for us. So cargo run. Okay, so let's test this. Cargo run should compile, and okay, does work. Nice. Okay, that's great. So everything seems to be working fine. So now let's take a look at the first chapter of our ray tracer thingy. And the first chapter actually says that we should define some common data structures, like a vector and a point and so on. I've actually not 100%, I've skipped through this, and so I have an idea on what we are going to implement. I might be pausing the recording in the middle, or cut it later on, because I won't have you getting bored while I have to read through some of these pages, seeing what we actually need to do. So, but the first thing is we are doing a test driven, so we need some possibility of executing tests. And as far as I have seen, you can somehow integrate tests directly with your crates. How are packages called? That's what packages are called in Rust, I guess. I've glanced, and there is writing automated tests. That's the whole chapter. So let's take a short look at that. How to write tests. We are needing to set obviously up all our stuff. So that's like testing libraries, I guess. And we can annotate certain things just with a test annotation, as far as I understand this, and then it will be executed as a test. So I guess let's just check this out. If this is actually, let's just create a very simple, yeah, maybe it's not, let's call it. Okay, let's just start by creating, we want to implement first, we want to implement a point. So let's do that. Let's create a module called point, maybe, with a function. So we have this test here, and then we have a function. Let's call it, what's actually the first test in the book to be created. So the first thing we are creating here are points and vectors. And it is said to be that we actually have something, it's actually something I think we cannot really create in Rust. So we can create a function and call it let's just call it can be created, maybe. So if we have this now, we should be able to at least say what the book here is saying is, I guess it would be something like, was it let? I don't know, maybe something like this. It's here, it's like 4.3 and minus 4.2 and 3.1. Yeah, and the fourth value would be y z. Okay, for now let's actually add this. And let's later on maybe make it impossible for the value to be something else than 1. I'm not sure if this is even feasible, if this can actually be done. So is the auto formatter actually working here? No, it doesn't seem so. Do I have a formatter? Format document? Great, this does not work. Is there a Rust formatter? Or is maybe my syntax is completely borked and that's why it can't be formatted? That most likely is the case. Rust format. Is there something like that? No. Okay, so most likely the syntax is completely different, and that's why it can't be formatted correctly. So that's how we define a user struct. So let's define a struct like that, and let's say pub struct point, and it has this one that is a float 64, I guess. Y is a float 64 as well. Z is a floating point number with 64 bits. And we have, can I do something like this? Would be great if I can do, but I'm not sure. Okay, so let's do it this way at first. And then okay, I cannot format this anyhow. So now let's take a look at how we create a struct, because that's most likely what we are doing wrong. Let mood user1 equals user. Okay, no, it seems actually quite right. What if I take a look at this? I'm not doing. Okay, it's not the equal signs. There need to be a colon, a double. Yeah, a colon. So maybe it's, come on, maybe it's formatting now. No, it's not formatting. Why isn't that working? The definition is all wrong, so it has to be this way. I'm not sure if there should be a dangling comma. Doesn't seem to be a problem. So okay, I can't format this anyhow. So okay, so maybe I'm not so sure about this. Let's remove this. Let's do it like exactly in the example. So we now have this structure actually. So now initialize it exactly like that. Wait a second. There should be a semicolon. What's about this? What's about this test? Okay, now for now let's remove this one and simply check if we have a. Okay. Now it has formatted, which is kind of great. I like that. So the question is not if this one. So now we can format code. That's good. We are starting really slow. So how does this testing work again? Writing automated tests. So yeah, it's simply telling the system test. So if I'm actually really doing this and telling it here, come on, test. It tells me that it cannot format this anymore? I don't get this. Is this essential to have inside the file, maybe? Not really. Do I need maybe this mod tests? It said that, wait a second, it said that this stuff can be nested actually, so let's maybe try this, mod test. Maybe it's some sort of magical naming, maybe the test mod, no, it doesn't format. So, I see why. I see the problem, I see the problem, I see the problem. It should have been there. Okay, it does not. Does not format anyway. Okay, that may be why. Okay, now it can format and it's running. And hey, great, I have a run test button here. Let's click this and see what is happening. Running 0 tests. That's kind of not what I expected. But maybe that is because now we have to add this. Maybe. Don't know. Let's check this. Run tests. Okay, there is no... Okay, but it could be that... Maybe let's not have this there, because I don't really know what it's doing. And let's do an assert true. And let's run that test again. And nothing happened again. Interesting. Doesn't make any sense at all. Let's try and check what this CFG like config is all about. Is there anything that is... It's maybe just telling the system that a certain module is full of tests. So maybe we really want this. So maybe that's the kind of magic we are doing here, that we are I could maybe name this module however I want, and it's like I have to configure it as, what was it, test here? Was this the syntax they were using? Yeah. And maybe now the system knows that these are the tests. Let's check. That's not really working. Running 0 tests. Why is it not running any tests? Okay, let's do something like this here. And let's do 2 should be 4. But that's of course completely false. So it should fail. Okay, it doesn't. So maybe... Actually, I'm quite never using this internal terminal, but let's use it because it's now more simple. Let's just say cargo test. Okay, so cargo build maybe. So maybe we need to, but I would have hoped that it does that automatically. Okay, it simply doesn't know that it should execute something. Let's remove this mod here and let's try again. Maybe that's the thing. No, it's not. Maybe I need to somehow specify that this file should be compiled as well. Let's take a look here. Is there anything? No, it's actually not. Unfortunately, it is not. So I'm not even sure how to... Let's just for now take this and move it to the main file here. Maybe we need to publicly define it. Field is never read. Okay, but shouldn't it be possible for it to... Variant or union type point in this scope not found. Okay, obviously I need to... Maybe this is what these use super star is about. Maybe, I guess. Unused variable point. Yeah. Yeah, okay, let's do this now and underscore it now. maybe, and then we can ignore the warning. And if I go to cargo test now, it should, okay, I see. So it gives me all these warnings and then says the test failed. Yeah, that should hopefully fail because 2 is not 4. Okay, so maybe we should take a more just do it and then refactor it approach to all this, because I haven't really a clue what I'm doing here at the moment in Rust, and I'm still learning. So maybe we should simply go with just pushing stuff into the first best file we find to do it, and then later on simply refactor it and move things out when we get a better understanding of how this works. So I guess I simply want to do it like, I'm not sure. Let's do it this way. So we have a structure here, and we should be, let's format this because it looks simply horrible. So we have this tests here now, and now it should be possible for us to do something with it. So the initial test here says, by the way, the values I've taken here are from this initial test, and they say, okay, we should create something like this, and then we should validate that it has these values. Of course, it will have those values, but let's actually validate this. What do they have first? Do they want the... Okay, they simply call it left and right, but the question is, assert failed. What do they actually... Is it the expected first, or is it the actual first? Is there any information about that? Function uses the assert equal macro to assert that 2 plus 2 equals 4. So the actual is the 2 plus 2, and so they have the actual first and the expected second. It seems to me that they have the actual first, which would be point x, which should be 4.3. So, and then we have y, which should be minus 4.2, and we have assert equals point dot z, which is point dot z, not sure, 3.1, and assert equals point dot w is 1.0. So is there a name for this thing? Point does store values. It's a completely useless kind of test here actually, because we are testing a language feature now, but okay, so now it is actually working like we want it to. I'm not sure if there is there an instance of kind of check in Rust? I don't think so, because it wouldn't make any sense, because there is no inheritance. Rust instance of struct, I don't think so, because everything is statically typed, and yeah. The question now is, after we've... Okay, but actually now this should go away here. Field is never read? Yeah, it is. It is read here. It is read here. That's kind of strange. Maybe it just didn't didn't get it yet because we didn't recompile it or stuff or something like that. Cargo build. No, it's actually saying that this is never read, but it is. It is in this. Or is this because it's a submodule or something like this? But it is not. That's kind of strange. But let's, for now, let's try something different. Can we have, instead of a type, can we maybe, no. Okay. Let's check if we can do this. Rust enforce struct property to have a certain value. In Rust, you don't specify mutability inside a struct, but it is inherited from the variable binding. That's great. But it is possible to force a field to be always immutable, even when the root is mutable. Okay. Yeah, okay, that's not directly what I want to see, but maybe I'm getting a better idea here. I see. Can't be seen outside of module. So how the heck are we doing this? Because if I'm understanding it correctly, what the hell? I assume this shouldn't actually work? Why does it? Let's make this crash intentionally. Let's make this test fail intentionally and see, okay, it is failing, but what the hell? Why is it? Tests point does store values. Ops functions. So that's kind of really, really, really strange. Because as far as I can see it, we shouldn't be able to accept this. Is there some sort of point struct which actually... Okay, so yeah, okay. I guess we are using the right point. I just wanted to make sure that we are not accidentally accessing some built-in point structure which Rust has, but I don't really get why. Okay, so let's see. Mod inner pub struct a si32. So they have a module here, they have a struct a here, then they have some sort of implementation on that struct. I see. So they create a new, okay, I see, there is a new, I see, okay, so now they can create a new a, and this is not allowed because they are not inside this module. I see. So okay, so what we could do actually is we make those all public. It still would allow us to create wrongly formatted points, but what we now could do is we could an implementation on point, and we simply make an implementation fn new, and this one should actually then get this. Okay, this one returns self, and now we could no, we don't need the return because the last statement, yeah, inside this blocks is always this. So we get we just take a floating point number here, x, y, z, floating point 64, and now we can say x, y, z should work with this short syntax, and then we can say the w parameter is actually 1.0. This should kind of work. Mismatch types. Expected struct point found tuple. Huh? Kind of don't understand. Why is this? I guess there isn't a semicolon allowed. No, I'm kind of confused, but okay. So or should we even have functions reading these values? I'm not sure what are the best practices in Rust are. So, but now we want to use new, and we want to do 4.3 minus 4.2 3.1, and then actually this test starts to make a lot more sense, because now we are essentially really testing some code we have written. So I actually like that, and it gives me the impression that associated function is never used. New, maybe it needs to be public as well. Okay, it needs to be public as well, because we are using it outside of the module, I guess. Not 100% sure of that. But why are we using it outside? Makes kind of sense, because we even don't want to test something which is private and not public. So, okay, one passed test. Okay, so the next would be to do the same thing for a vector. So yeah, let's kind of do this. Let's create a vector. So we more or less copy this code, vector. This is a vector as well then, and it's essentially the same, but the w parameter here is now 0. So we can essentially copy, can essentially copy this as well and say vector does have w of 1 and stores values. I'm actually, let's do this. Let's actually create two different tests for that. I don't know what the best practices are, but I'm a big fan of atomic tests, even though the book has a different approach here, but they are doing gherkin tests there, so so cucumber actually. So point does let's just point new does create point. So let's do this, and let's not check this here. That's kind of where I would want to check that the point new function actually gave us a point. But I guess that's completely useless here, because we have defined it as returning a point. So the compiler would already tell us, yeah, it's kind of, does create point is maybe not right, does fill point properties. Fill properties. Yeah, I guess that's okay. So let's take this one and kind of copy it here. And now let's do this vector kind of stuff here. Let's call this vector. This is a vector. Do they have different values for the vector? No, they have not. So vector, vector, vector. And now this is point has w value of 1. So let's create it again, and then let's just check this value here. And I actually want this one here then, and I need it again, and I need it here. And this time it's a vector, and vector. This one is vector as well. I could have done with a replacement, but who cares? So yeah, now let's, what did I do? I've clicked somewhere I shouldn't have. Cargo, test. Test failed. Tests, vector has a w value of 1. Failed. Yeah, sure it failed, because we should have made sure that it has a w value of 0. Okay, so now it's passing. That's great. So the longer I'm thinking about this, the more I'm guessing that we actually maybe want one struct, and we simply want different instantiation functions for that. Shortcut functions to create a vector or to create a point with these specifica, because essentially they are actually the same thing. But how do we call this basic data structure? I'm calling it tuple now, if this is allowed, because why not? And then we can actually do something like tuple, and we can have a function here called point. And then we have this function which is called vector. This does a lot more sense. So in my eyes, it makes a lot more sense to now say tuple. What are we actually testing here? Point. Maybe some of you are just crying out now because I'm doing something horrible here, naming regards or implementation with implementation regards to Rust, but I don't know, so I will find out. Vector has a value of 0, so tuple vector. So now we are talking. And I would assume these tests are still running. Yeah, they are. So, okay. The next thing the book is talking about is actually comparing floating points for tests, which is of course needs to be sort of a fuzzy comparison, because they might differ by a slight value, slight epsilon. Let's check out if Rust actually can do that. Compare floating point numbers. Is there something like that? Float comp. Is this create float comp? Float comp defines and implements traits for approximate comparison of floating point types which have fallen away from exact equality due to the limited precision availability. Yeah, of course. So I'm not sure if this is, it seems quite nice, but I'm not sure if this isn't too complicated for what we are going to do here. So maybe we are just creating our own float compare function. Pub_fn. Let's call it f64 fuzzy equals or fuzzy EQ. So, and it takes left f64 and right f64 and maybe an epsilon. Ceylon, which is an F64 as well. Do they have, is there a way to have something like, what are they suggesting here? 0, 0, 0, 0, 1. Is there a default value thingy in, obviously not, or not in the way I guess it is. Rust. Default arguments. Is there any default? Okay. Let's just not allow this here and simply do a let epsilon equal 0 dot 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Yeah, that sounds like a reasonable, maybe a reasonable thing to do. So, question is, do we have something like absolute? Do I need to seems to be there. Okay. So let's just take the absolute value of this one, and if it is smaller than epsilon, we are, by the way, we should return a boolean here. Yeah. We should return true, and otherwise we should return false, but okay, cannot find function apps, but nevertheless this does not, it's not nice. So let's just return this, I guess, and see if we can. Okay, so Rust math absolute. I guess I need to import it somewhat. Okay, it is implemented on. How does this work? I see. It's implement. Okay, that's something I definitely have to learn, because it's somewhat different from what I used, but it absolutely makes sense to implement this as a trait, it seems, on different types. I guess that's what this kind of is, most likely. Maybe. Let's take a look. Pub fn apps self. Method returns a number and does not mutate the original value. I guess this should work. As this has taken up quite some time, I guess I will end this session after I've implemented the first operation on our data structures, which is simply an addition of tuples. So we have to figure out how to implement or to override the operations in Rust. Operation override Rust. Operator overloading, that's what I was looking for. So standard ops trait is used to specify the functionality of plus. Okay, so we make add bar the trait for addition with the right hand side of type bar. Makes sense, kind of. So we implement this trait, and then we can simply, okay, that kind of sounds quite cool. I'm starting to like Rust. So we should actually be able to. What I actually want to add here is something else in the tuple implementation. I want something like pubfn is point, which returns is it a boolean or a bool? It's bool. Okay, so let's do this, and then let's simply do. I guess we get a. What is it? A reference to self? Do we get a reference? I hope self dot y. Okay, there is only a double comparison in Rust. You never know. So that's if it's a point, it's actually 1.0, and I want something telling me if it's a vector, because I'm guessing I need to somehow differentiate between those two. So now we can add this to our tests, like point says it is a point, so let's create that, and then let's assert that point is point. So, and this one, and let's put it there and set to it point says it is a vector. Vector. So, and let's call it vector as well. So, let's run this. Why is there? Okay, because I've okay, it really runs this specific test. Oh, that's nice. That's a nice integration. Okay, so all tests pass. And it's reasonably fast. Okay, we are not compiling much here, but it's reasonably fast. Okay, so what I wanted to implement was add. So if I understand this correctly, what I'm now doing is I'm saying impl ops add I guess ops add self. Not sure if this is possible for tuple, I guess, maybe. Do I need to somehow declare this as being used? Use std ops, I see. Okay, so use std ops. Not all trait items implement missing output. Add missing output. Add an implementation. So, okay, so I guess this is what this is here, type output. So is this actually, it seems to be needed? Okay, so I can have a type within a trait. Okay, I will need to read up on that, but for now I will simply say output equals to self, I guess. Okay, so not all trait implement missing add. Yeah, that's right. That's what I'm going to implement now. So fn add, what is it? Self. Yeah, and then the right-hand side, I guess, which is a self, and it returns self. Yeah, okay, so I'm not sure if I should actually be more expressive about this here and say tuple everywhere, but seems to work. So yeah, we could simply return self here for now. Because I actually want to write the test first. Yeah. Come on. Test. I've recently reconfigured my keyboard layout slightly, and so I'm always punching the wrong keys, but it will get better as well. So what are the tests here? Essentially, we just want to check that tuples are added up. So what we want to check here is actually let tuple equals tuple x, what is it here? It's 3, it's y is -2, and 5 for for z, and w is 1. And we have, let's call this tuple 1, and this is tuple 2. And then this is -2, 3, 1, 0. Mismatch types found. Okay, I actually need to specify these this way because otherwise he won't actually know it is a float. Okay, accepted. So now we need let expected tuple. It's a tuple and it's x, which should be 1, 1. No, I need it like this. 1, 1, 6, 1. Yeah, I guess that is right. Yeah. Okay, I see. Maybe I should create a convenience function for that. Let's simply do an assert equality between the actual value, which would be tuple 1 plus tuple 2 with expected tuple. Not sure it can actually compare these two, but let's test. Okay, there is something wrong. Tuple cannot be formatted using whatever. So tuple doesn't implement debug. Binary comparison cannot be applied to type tuple. So yeah, I guess we need to implement that as well because it would make a lot sense. So I guess that's another operator overloading thingy, I guess. Okay, why the heck can they be compared here? Copy, clone, partial. Okay, there obviously is something I can somehow attach there to make things nicer for us. I will somehow attach this here now, which obviously makes things better, but let's kind of check what happens then. Test failed. 3 minus 2, right. So 3 minus, yeah, of course it is failing because we haven't implemented it yet. Okay, so let's do this. Where have we been here? We now need to make it like this. So what we want is we want to output a new tuple, which is kind of self dot x plus self dot y. Oh no. Right hand side dot x. Sorry, it's like this. So now we have y is self dot y plus right hand side dot y, and z is self dot z plus right hand side dot z. And w is self dot w plus right hand side dot w. So it's kind of like this. And essentially, I'm hoping that if I do a test, I execute a test now here, it passes, but there is something. Identify to snake case. Ah, yes, I see. I see. We are supposed to use snake case with within. What have I done wrong now? Tuple 1. Okay, there's something really broken now. I see. Okay. Yeah, that's quite nice. I guess that's a good position to stop it for now. And yeah, it's fun. It's really fun, even though we are very slow at the beginning now. But I like how it's going forward and how I already getting to know Rust a little bit more. So thanks for watching, and see you in the next one. Bye.